The chemical element boron is categorized as a metalloid. A metalloid combines the characteristics of nonmetals with metals. It is the first element with an atomic number of 5 in the 13th column of the periodic table of elements, denoted by the symbol B. Boron is dark, brittle, and glossy when it is in its pure crystalline state. Among its many uses are in fertilizers, pesticides, detergents, cosmetics, insulation, flame retardants, and antiseptics. It can also function as a semiconductor. The Arabic term al-borak, which refers to the mineral borax, is where the word boron originates. Earth has found boron in rocks older than 3.8 billion years and in meteorites that have fallen from Mars. Borax is the most prevalent source of boron on Earth. Before borax was ever identified as an element, it was utilized for thousands of years. Borax was used in China's pottery glazes about 300 AD. In the 8th century AD, it was also exported as crystalline deposits from Tibetan lake beds, where goldsmiths and silversmiths employed it as a flux. In 1808, French scientists Joseph L. Gay-Lussac and Louis J. Thenard, as well as English chemist Sir Humphrey Davy, concurrently identified and extracted boron as an element. Davy heated borax with potassium to generate boron. The element he named brachium was just identified. In the meanwhile, Thenard and Gay-Lussac employed iron rather than potassium. However, pure boron was not produced as a result of their attempts. 100 years later, in 1909, American scientist Ezekiel Weintraub is credited with producing pure boron. Weintraub combined hydrogen, boron chloride vapor, and the element to produce the pure form. The atomic number 5 and the symbol B are used to denote boron in the periodic table. 5 protons, 5 electrons, and 6 neutrons make up boron. The element boron is a member of group 13, sometimes referred to as the boron group. It is a component of the periodic table's p block and period 2, the second row. 10.811 U is the atomic weight of boron. It has a melting point of 2076 degrees Celsius and a boiling point of 3927 degrees Celsius. Boron is a solid at room temperature. Of all the metalloids in the periodic table of elements, boron has the highest melting and boiling values. Boron has a density of 2.37 grams per cubic centimeter. In covalent bonds, which are chemical bonds in which atoms share electrons to create electron pairs, boron is more stable. Typically, it doesn't create bonds by taking electrons from one atom and giving them to another. This process is known as an ionic bond. Boron ionic bonds are hard to establish because borons are tiny and have a high density of charges. The dark hue of crystalline boron can be silvery, brown, or black, and it is glossy. When it is an amorphous powder, it can be reactive, but when it is crystalline, it is not. Although significant doses of boric acid can disrupt the body's metabolism, it is normally not hazardous. With a MOS rating of 9.3, crystalline boron is regarded as the second hardest element after diamond. It may be too fragile, even if it is solid, to be utilized in tools. Because of its strong semiconductor properties, it may act as an insulator at low temperatures while conducting heat and electricity at high ones. It is thought that boron is more stable than carbon. A flame test may be used to determine whether a substance contains boron. If it burns brilliant green, it does. It is stated that boron has 13 isotopes. When an element has the same atomic number but a different atomic mass, it is called an isotope. There are just 2 stable isotopes of boron that are found in nature, boron 11, which is abundant at 80.1%, and boron 10, which makes up 19.9% of natural boron. Neutrons make up 5 of the atoms in boron 10 and 6 of boron 11. There are 4 main allotropes of boron, which are distinct structural variations of the same element. Both on Earth and in the entire cosmos, boron is an extremely uncommon element. It is not a pure element that exists in nature. It is typically found in substances that are extracted from sedimentary rock formations and deposits in the Earth's crust, such as borax and boric acid. The largest boron reserves in the world are found in Turkey. Turkey is home to over 72% of the world's known boron resources. The United States of America is the second largest producer of boron. There are abundant boron deposits in Chile, Argentina, China, Russia, and other countries. The Mojave Desert in California, USA is home to keynote, often referred to as azurite, which is the primary source of boron. Plant development greatly benefits from the presence of boric acid, especially in the cell walls of plants. Animals are not poisoned by little amounts of boron. Boron is utilized to make pyrotechnics and other fireworks because to its brilliant green flame. Steel can also be treated with boron to make it harder. Glass may also be made more resistant to thermal shock by adding boron. For this reason, borosilicate glass is used to make some cookware and glassware for laboratories. Using amorphous boron to light rocket engines works well. Because it absorbs neutrons, the boron 10 isotope is a perfect material for controlling the fission rate in nuclear reactors. Both nuclear weapons manufacture and medical imaging employ the boron 11 isotope. Structure materials in airplanes and spacecraft are made of boron fibers. The majority of boron that is extracted from deposits is processed into boric acid or borax. Borax has been used for thousands of years and is still widely used today as a detergent and cleaning product component. Borax is also utilized in tile glazes and cosmetics. An efficient pesticide for fleas and cockroaches is boric acid. Additionally, eye drops, flame retardants, and substances that inhibit the spread of fire all include boric acid. An excellent material for tank armor and bulletproof vests is boron carbide. Diamond dust can be replaced with aluminum boride while polishing and grinding. Don't forget to subscribe, like, and hit the notification bell to stay updated on more exciting content from Junior Library's Whitey Classroom.